Now in this lecture we covered the topic on control strategies, and we take the example of a distillation column. So the example for this case is distillation column. Now the distillation column can have a set of control problem. So suppose one of the problem if you want to maintain the top composition. Now as I said that each control problem starts with the objective. So for this case, suppose the objective is to maintain XD, the top composition. So let's assume we have some basic understanding about the operation of a distillation column. So let's look at the diagram of a distillation column. So feed coming in, top product going out, the vapor from the top going out, being condensed, part of it is sent as reflux, and part of it is collected as the top product. The same thing for the bottom, coming in, going to the reboiler, the vapor going back to the column, and the liquid product is coming out. Okay. So this is the feed. So feed quality can be anything like the temperature or things. And there are the trays or it can be a back column as well. Just to give a simple description of the operation of the distillation column. Now, typically, the top composition is maintained by manipulating a variable. Now, when you define the objective to be to maintain the top composition, so your output variable is the top composition. So again, you recall the variable that you want to maintain, that's the output. Now the variable that you need to manipulate or you chose to manipulate to maintain the output is called the input variable. Typically for a distillation column operation, the output top composition is maintained by manipulating the reflux flow. So for our case, suppose the input is the reflux. But that's not the only choice, there may be other choices as well. Now again, if you recall the definition of disturbance, other variables that may affect the output, but you cannot or you chose not to manipulate. Those are the disturbance. So one disturbance for this case can be the feed quality. So we'll simply call that, maybe the temperature, will take an example, but any feed quality can be the disturbance for this case. Now, the one control strategy for this distillation column may be you measure XD you compare with the desired value and calculate that if the desired value and the current value are not the same, what needed to be done. So if XD is below the desired value, you may increase the reflux flow. If XD is above the desired value, you may want to decrease the reflux flow. In the third step, what you do? You manipulate the reflux. So that's one control strategy. What you are doing in this case, you are manipulating R. What is the input for this case? based on the measurement of the output, which is the output for this case. So I'm manipulating the input based on the output measurement. But what else can you do? Suppose this feed temperature affects the top composition. So if you observe that there is a change in the feed temperature before the top composition changes, you may manipulate the reflux in a way that will give you the desired top composition. So for the second strategy, what you can do, you can measure the feed temperature. You can do some comparison and calculate what needed to be done, meaning that how much change you need to make in the reflux flow, and then manipulate the reflux. So for this case, what you are doing, you are again manipulating the same input. However, for this case, the input manipulation is done by the measure disturbance. So for the first case, some disturbances enters into the process. The change is taken place in the output variable, and you are sending that information back to the system to take some control action. For the second case, disturbance is entering into the process, so you measure the disturbance, and before the output is changed, you are sending the information to the process ahead of the change in the process or in the output, so that the controller can take some action. So these are two control strategies. Again, this is what is called this feedback control. This is what is called this feed forward control. Okay. So the two name comes because for the feedback case, the information is being sent back to the process when there is a change, already change in the output. For the second case, the information is sent ahead of any change in the process output. So why do I need both? Suppose for a distillation column, if there is a change in the feed temperature, that may affect the output, but that can take place maybe depending on the size of the distillation column. It may take, the change may take place after 10 minutes, 20 minutes, 30 minutes or something like that. Now if you anticipate the change, why do we wait for that time? Instead you can measure the disturbance and take action before the output is changed. However, there may be other variables that may cause change in the output. So always you need to measure the output, and then based on that need to manipulate the input. So typically feedback control is the dominant control mechanism, but for many cases like this one, so you may have to have feed forward control. So feed forward control typically is not applied by itself, rather it's used along with the feedback control.